Okay, this is chapter 2, problem 95, and I'll make it very quick. And you have gone back in time and working with Dalton on the table of relative mass. So we know that Dalton, he has to do some research about chemical reactions. And the only thing he knows about is weight, which is mass, because he does not have some spectroscopy or some analysis tools that can help him define what composition is in the chemicals. So only thing he can do is using mass weighting. Like, okay, so the composition is over here. That they do experiments. They conduct experiments and find out the ratio between A and B, B and A and C is like this. 就是我们发现这个去进行反应的这个什么的相对的质量。Okay, so there's a students ask me about if we want to calculate the relative mass, should I written out a final ratio, or just written out a single compound's relative mass? So about this, here is how you should comprehend and write down the answer. Is you have a relative mass for somebody, and you write down what should other have the relative mass look like. For example, if I have 6 grams of A, and how much weight or how much mass should B and C have? So the calculation is like this. I'll leave it to you because I think it's easy. But just for information, when you have calculate to some digits, 就是小数点 like this, to make it integer because it's close to 6 enough, and just for convenience, just make it 6. Really, I mean it. So the calculation, I think you can read it by yourself. Oh, in the question B, this students ask, when we are finding out what kind of composition is inside the gas A, gas B, and gas C. So he actually asked a good question. Isn't it possible that A and B and C is not a monatomic gas? 就是说这个 A, B, C 可能不是这个单原子气体。Of course. So in part B, you just have your assumption. 就是你随便假设。You have your assumption, and it is correct when you put inside the formula over here, because we know that the gas of volume is proportional to the moles of gas. So when you put inside this and you do calculation over here and you find, okay, this is fine, then you do the same thing as part A do, like this, 6A2 over B4 is same as the ratio of 0.602 grams of gas and 0.295 gas of B. Then you can find out the relative mass of the gas, but this time is A2, B4, C3 over here. I think you can read it now. Okay, so you do the same thing as part A. Relative mass of A2, B4, C3. Notice that I used the small letter and capital letter in the first part of this question. So then now you can find out the relative mass of little a, little b, and little c, which is 6 to 9 to 7. And I think you can read it by yourself. And I will send you this handnote by PDF. Okay, thank you.